In this video tutorial, we're going to cover the data pipeline portion of our trading bot that uses AWS Cloud to automate the entire process. And so as you can see in the architecture diagram, I have outlined the portion that we're going to cover today in this video in the big orange box. So I'm going to demonstrate how to use Python code to interact with the Yahoo Finance API, as well as our DynamoDB table, which is going to hold our price data. I'm also going to show you how to create an AWS user, which will allow you to interact remotely with AWS services. And here we have the quick outline of what my goals are for this particular video. And so number one, we're going to start with how to create an AWS user so that we can use Boto 3, which is the Python package that will allow us to connect to our remote AWS services. And then after that, I will show you how to create the DynamoDB table that we will use to store the prices, and then how to configure the local AWS client. And after that, we will get into the code part of this, where we will discuss the requirements that are needed to create the data pipeline, and then I will go over the actual code itself, and then we'll run the code to populate the database to ensure that everything is working properly. And then finally, we'll cover the unit tests, which will help us capture any bugs that might have slipped in to the code. And that part is also very important because eventually we would like to use this code to trade live, and so we want to ensure that it is stable and robust, and we want to try to capture any bugs that are created now, and if we make any changes to the code, that they will be captured later on as well. Okay, so after you create your account with Amazon Web Services, you'll be greeted with the console home. And so you might not have all of these recently visited services, but the service we want here is the IAM, right? It's time to create our user. Our user is going to be the identity that we use to access these services remotely, specifically our DynamoDB. And so to do that, we're going to click on IAM. And if you don't see that when you log in, you can always search for it in the search bar, and it'll bring it up here, and you can go to the IAM service dashboard. Now here we're going to create our user. I already have a user here, but we're going to create a new one for this project. We're going to give our user a name, AWS Algo Trader. It's fine. We're going to click next. Now the next portion is to set the permissions. So this is one of the benefits of using a cloud provider like AWS in an enterprise setting, right? Because you can be very, very specific about what permissions are allowed for what user and for what roles. In our case, we don't have a group created at the moment, so we're going to attach policies directly. And what we really need is DynamoDB, right? And here we have Amazon DynamoDB full access. That's what we want. And this is just showing all the different abilities and permissions it's going to give our user. In this case, this is all we need to connect to our DynamoDB and read and write from it, or read from it and write to it. So we're going to click next, and it's telling us our permission summary. Again, we just need DynamoDB for now. That's the only service that we're using. So we're going to create the user. The user is created, but right now we don't have an access key or a secret key. And so we're going to have to create that. So we click on our user that was just created, and you can see in this corner we have create access key. We're going to click that, and we're going to use the command line interface. We're going to say I understand, and then we're going to click next. Create access key. Now we have our access key and our secret key. You want to make sure you save these credentials, download them, and then once that's done, you're going to click done. If you find this content valuable, you can help support the channel by commenting, like, share, and subscribe. If you would like to collaborate with me on your own personal projects, if you need a strategy for your own personal portfolio that is fully automated, or you need help developing your Python developer skills, especially as it applies to algorithmic trading and automated trading, the links are in the description. Okay, the next step before we leave the console, we need to create the price table that is going to hold our data. And in this case, we're going to use DynamoDB. And so we're just going to click that. And just remember, if you don't see it, you can always search for it in the search bar. And you're going to see in the left sidebar, we have dashboard, we have tables. We're going to click tables. So you can see I already have some tables that are operating, but we're going to create a new one for this project. Create the table, give it a table name, AWS, call it price. So we're going to call it price history table. The partition key, that is going to be the ticker. You can call it a symbol, instrument, whatever you have, or whatever you prefer. Next, we're going to create the sort key. Here, we're going to use the timestamp, and that is also going to be a string. Both of these are string types. You'll notice that we don't have to actually create the columns at this point because this is a NoSQL. So we'll actually create the columns when it's time to populate the database or the table. At this moment, we can leave everything as default and just create that table. And then in a few moments, this table will be ready for use. Okay, now our price history table is ready. And so we can click on it and just kind of look at a couple of things that will be important once we populate the table with data. So we can see that our partition key is set, our sort key is set, and then we have this little widget that is going to give us a live item count. And right now it's at 0 because it's empty. In the top right corner, you're going to see this explore table items. Once it's populated, you'll be able to see examples of the items that are in your table, and you'll also be able to run filter queries and sorts if you want to find a unique item or you want to make sure that a particular data point is populated within the table. Really quickly, I wanted to cover something that I forgot to mention. So obviously, the data that we collect is going to be really important. And so there are protections that we can put on our tables to avoid accidental deletion or for recovery purposes. Now, they offer a service called point-in-time recovery. This costs money, so you'd have to decide if it's worth it for you. But the minimal level of protection that you can give for your table is to turn deletion protection on. And so we're going to handle that now. And to do that, so we went to additional settings and we're going to turn that on. And now we're all set, and that is it. There are a lot of other options, but for our purposes, this is good enough to start with. Okay, now we're at the portion where we're going to configure our AWS client to utilize Boto 3 and connect to our DynamoDB table. And before we do that, we need to ensure that we've already installed the correct packages. Make sure that we install the following. Now, I already have these packages installed, but I just wanted to show you the commands. It says that all the requested packages are already updated. We will then configure the AWS client. Okay, so we can see that the requested packages are already installed. And so now we're going to configure our client. Let's configure. Okay, so now we're going to need our access key that we downloaded before, and then our secret key, our default region name, that's going to be, for me, US East 1. output format. I'm going to use JSON. And now we are configured. So this is going to let you connect now. By default, you don't have to pass in your access key or secret key in your code. There's a configuration file that is stored where the AWS client will look for your credentials and will be able to connect. So I'm going to demonstrate that now. Okay, now here I'm going to demo how to use Boto3 to connect to our price table, just so you know that the configuration works and is completed. So first we're just going to import Boto3. We're going to give our price table region name, correct table is the table name, and we're going to print the table, and it should return a DynamoDB table object if everything is good. So we can see that it worked. So the connection is working, the configuration is right, and so now we'll get into the code. All right, before we get into the code specifically, I wanted to touch on one of the things I do in the process of coding a project. And the number one thing I like to do is clarify the requirements. And with this data pipeline, we need to be able to do what? Query the Yahoo Finance API. We need to be able to pass in a start date, an end date, period, time frame, things of that nature. Next thing we need to be able to do is format the data for storage. So typically the data that we receive, or the data types that we receive from the API is going to be different than the data types that need to be stored in the database. And in this case specifically, DynamoDB, for example, requires that all numeric data be in decimal format. Next thing we need to be able to do is query our DynamoDB and get the latest records. And we need to be able to tell it how many records we want at any given time. We also need the ability to determine how many days of data we need to grab from the API in order to update the table. And to do that, we need a function that can compare today's date with the most recent date of the most recent item in our DynamoDB table. We also need to be able to update the table with our price data. And if available to us, and it is in DynamoDB, we need to be able to bulk insert the new prices. Usually batch inserting or bulk inserting is going to be faster. Okay, before we get into the details of the code, let's discuss a little bit about what's happening on a broad scale, right? From a bird's eye view, right? So essentially we have a couple of things going on. We need a structure with methods to be able to communicate with the Yahoo Finance API, and then we need a class or structure that will allow us to handle our database operations. And from there, we're going to wrap all of those things up into an easy to understand function, right? So we have one that is called warm-up asset data. In this function, its primary purpose is to populate our DynamoDB table initially if it has no data. The next function is simply to update that price table if we have data in it. That's all. So very simple understanding of what's happening before we go into the details. And then just to touch on briefly this function, the init DynamoDB, that just sets up our resource and connects our code to the Amazon Web Service DynamoDB and our price table so that our functions can access this price table on a global scale. And here we have a code flow diagram so you can understand how everything is working before we get into the nitty-gritty of the code itself. And so as I said earlier, there's the initialization of the price table, and it doesn't call any other functions. And then we have our main two functions, right? And the number one function we start with is the warm-up asset data. And what that is going to do is it's going to query our DynamoDB table and see if it has any data. If it has no data, it's going to grab the data from the Yahoo Finance API as much as it can, right? And once it gets that data, it'll put it into the data table. And so you can see and follow the arrows. The next function is the update price table, and that does exactly what it sounds like. It's going to query the DynamoDB table, get the last record, and then get the date from that record, and then compare it to the current date. And if there is a gap, it will call the Yahoo Finance API, download the new data, and then put that data into the DynamoDB database. Very simple. Okay, so now let's get into the nitty-gritty of the code. So first things first, we have our imports. The key imports here are going to be Boto3 related, as well as Y Finance, which is going to allow us to connect to the Yahoo Finance API. And here is our class. And it only has one method, meaning one function inside of it, and it's the get price history function. This is the function that is going to do the heavy lifting in terms of grabbing the data from Yahoo Finance. All right, looked at the data before. We don't need these two columns, so we're going to drop them. The symbols that we're using don't have capital gains or stock splits, but you'll want to adjust that if you decide to utilize regular equities. We are, in this tutorial, we're using currencies and ETFs. So if we pass in the period parameter, this is how we're going to structure the call and format it into a data frame that we can utilize. If we have a start date without a period, or excuse me, if we don't have a start date and no period, then we're just going to get the maximum amount of data available. And then if we have a start date and an end date, we're going to use those to query the data. Now, if there's some combination that is not covered here, we're going to raise a value error, and then it's going to try to help you understand what's going on. Earlier, I discussed how the data types from our data frame or from the API is likely going to be different than what the DynamoDB requires. Here, we're going to convert that data into the numeric data into a decimal type, and that's happening here. You can make a design choice if you want to abstract away this into a different function or something like that, but here I just included it all in one. So let's close that up. Next, we're going to get into our database operations class. This has 4 methods, so let's touch on those. The method that interacts directly with the database in terms of querying the last record or the last n records is query last n prices. A couple of things I want to touch on. So we're going to query it based on the ticker, and the ticker needs to equal whatever we pass into the function. We want the scan index forward equal to false. So that will set it up so that the most recent records are at the top, so that when we call, for example, a limit of 5, it'll bring the 5 most recent records, with the first record being the most recent. Now, there's a couple of quirks to this that I noticed when I was building this out. The first one is that when you pass in n equal to 1, it doesn't return a list of dictionaries like it normally would. It returns just that single dictionary. Now, normally that wouldn't be a problem, but you don't want to have functions return different data types in general. that creates a lot of problems for your code and unnecessary complexity, and it makes it really buggy. So if this is the case, if n is equal to 1 and it's not a list, in fact, we could change this to make it specifically a dictionary. If it is a dictionary, then we want to wrap it as a list. If it's not a list, then there's a type error. Something's wrong, and we need to manually intervene to see if the DynamoDB API has changed, or if, essentially if it's changed or we're getting an unexpected response, we need to come in and fix that. Now, getLastNPrices wraps that function. And so this essentially will go through each symbol and gather up all of the relevant records, change the data types as needed. In this case, for example, the timestamp is a string in the DynamoDB table. We need that to be a datetime object. And we convert the numbers into quantized floats. And then we wrap up all the records and return a data frame. So it just makes it easier to work with. The next wrapper function that we have is the put price data in table. So we have two main parameters that we want to pay attention to. That's bulk insert and overwrite. And typically you would use these, overlapping. Like if one is true, they're both true. If one is false, they're both false. But we'll discuss that. Here is where we're going to establish what columns we want to keep in our DynamoDB. Because it is a NoSQL type of format, we didn't have to tell it, we want to keep a open column, a high column. No, we're doing that now. So in this tutorial, we're going to keep the ticker, the timestamp, the open, high, low, close, volume, and dividends. The timestamp format is specific, so you can see that here. And then here we go. If we choose bulk insert or overwrite, we're going to use the DynamoDB batch writer, which is a little bit faster, and it'll put more items in at once. Otherwise, we're going to use our put price items with condition. And so let's talk about what that function is. So put price items with condition. This essentially protects our DynamoDB from putting in data that is already existing. So that's really all that's happening here. There's a couple of parameters to pay attention to. So the condition expression is what we're using in order to manage this process. And you can see that we have attribute not exists. The timestamp label is actually protected in AWS. And so if you use that directly with attribute not exists, it will generate an error. And so you have to use this additional parameter called expression attribute names. And you can put an alias. And in this case, we're using #TS. Next, we have our, assuming that the item does not exist, it will be a successful put operation, and we log that information as well as the response. What happens if this does exist? It actually generates an error, but the error is not something that we want to deal with. We actually want to pass that error or catch that error. And so that's what happens. If we get the client error, if the code is a conditional check failed exception, that's okay. We just get a warning, and we know that that data already exists and that there was no overwrite that occurred. Otherwise, if there's any other type of error, it's unexpected, and we actually do want to raise and stop the program and understand what is happening. So that is it for our DB operations. Okay, next let's talk about the warm-up asset data function. And so as I mentioned before, all it does is essentially query our database to see if there's any data that exists If there's no data that exists, it's just going to get the maximum amount of data that it can from Yahoo Finance API for the symbols, and then put that into our DynamoDB table using the batch writer. Everything else is just edge case handling. For example, we always want the item to either return a list or be none. So if that's not the case, we want to raise an exception. If item is not none and it's not an empty list, then we know that there's an item and the function will just return. Otherwise, we know that the item is empty and that our database or our table has no data, and it's time to grab as much data as possible and upload it. Next, we're going to discuss our update price table function. And as I said before, and as it's properly labeled, that's exactly what it does. So it's going to get the most recent record in our DynamoDB table, grab the date from that, compare that date with today's date, and if there is a gap, it will query the Yahoo Finance API and grab the difference in price history and then upload that into the DynamoDB table. Here, this is just an edge case where if it's equal to 1, we want to use a period equal to 1 day. If we use the start date and end dates, it won't return any data. If it's larger than 1 day, then we can use the actual dates. To avoid a start date that overlaps the date that's already in our DynamoDB table, we add 1 day to the start date. If you query for a different time frame, you're going to have to adjust this according to your use case. Okay, I want to touch on the init DynamoDB function. So this is what connects our code to the AWS service and returns our table so that we can do table operations on it. One thing I wanted to touch on is that we are creating a session and then using that session to connect to the resource, which is DynamoDB. Now here I specify a profile name. Normally you don't have to do that, especially if there is only one set of credentials. However, if you have multiple sets of credentials, you'll need to set a profile name. Otherwise, it's just going to use the default credentials. So that is the only thing I wanted to touch on there. And once we connect, it returns our price table, and then our previously discussed functions can access that price table to do operations like query and inserts. Okay, so now that we have covered the code, what it does and how it works, we are ready to import the price data from the Yahoo Finance API and populate our DynamoDB table. So let's do that now. Okay, so we can see that we have finally finished. It took about 30 minutes to upload all of the data, but we can see that it is now populating our DynamoDB table. And then up next, we will check and confirm that using the AWS console. Okay, here we are, and we're just going to quickly confirm that we do indeed have our DynamoDB table loaded with data. We can see that the item count is the same, 15,252 items. And we can explore our table items as well, and we can see an example of the items that are uploaded or inserted into our data table. And everything is as we would expect. So in the beginning, I said that I would cover the test suite that I created for this, for the data pipeline, but this video is already running a little bit long, so I think I'll just point you to it. It could actually take up its own entire video, but the tests are there if you want to run them. All of this can be found on GitHub. Just run Python tests, be able to see that here, and everything passed. So if you are interested in more details, I could create a video for it. Otherwise, I would just recommend you explore the GitHub. If you are interested in testing, testing is very important, but I don't want to make this video too much longer. If you enjoyed this content, let me know. Okay, welcome to part 2, AWS trading. And today we're going to discuss the strategy that we'll be implementing. And just to note that the code and the diagrams for the strategy can be found on GitHub. So note, in part 1, we covered the data pipeline portion of the AWS trading bot architecture. I demonstrated how to set up the AWS environment, including creating a simple DynamoDB database or collection of tables, essentially, to hold our price and strategy data. Then we walked through the data pipeline code in detail, and at the end I showed you how to get the data and populate the DB with it. In this post, we'll be covering the strategy that we're going to implement. As a quick aside, I did try to make the architecture relatively modular. So if you have a different data API or you want to use a different DB, you can do that. But I just wanted to make something that was relatively accessible for most people who might stumble across this. In this example, we're using the Yahoo Finance API, and again, the DB is DynamoDB. So the strategy. In the end of part 1, I needed to choose a strategy, and I wanted to do something a little bit more interesting than a moving average crossover, which is essentially the hello world of algo trading. So I decided on a market neutral, long only ETF strategy. It sounded interesting to me to implement and to kind of do some basic exploration around. It does have some quirks though. Since it's long only and we need it to be market neutral, we initiate the synthetic short positions by purchasing inverse ETFs. So overall, the strategy is a pairs trading strategy. In this strategy, each pair will be equally weighted, and then within each pair we allocate market neutral weights accounting for the leverage of the inverse ETF. So just keep in mind, most inverse ETFs are in fact leveraged. So if we were using a 3 times leverage ETF and we had a $100 portfolio, we would invest $75 in the unlevered portion. In this example is XLF, and $25 in FAZ. So a 3-to-1 ratio, unlevered to levered. So now we'll explore a little bit of the theory about how we expect it to make money. And I did that a little bit in the exploratory analysis. So we have to consider market direction and volatility specifically. And volatility is especially important because of the leveraged inverse leg. And we'll talk a little bit about why in a second. But in theory, we expect the strategy to perform well in moderate to strongly trending markets. This strategy will get cooked in high volatility range bound markets. And this is because of something called volatility decay or beta slippage, or there might be some other terms that you might come across. But essentially the idea is that for a sequence of returns, there will be a gap between the underlying theoretical leveraged return and the actual return from the leveraged inverse ETF. Now, this results from the fact that the inverse ETF has to rebalance daily to maintain the proper leverage. And they do this by literally buying high and selling low, right? So they have to buy in the direction of the increase, and they have to sell in the direction of the decrease. So I detail more about this concept in a previous blog post that you can click here to find. And I go through it in detail and examples of what is actually happening under the hood for why this phenomenon occurs and why most people don't understand it. So here's a little bit matrix about how we expect the strategy to perform based on market direction and volatility. and we split the volatility into three regimes: low, moderate, and high, or low, medium, and high. This is a little bit more of a detailed exploration of that idea using XLF and FAZ. And we talk about what happens in each leg given the volatility and direction. And you can see sideways, again, because of the severe decay losses, we do not expect we don't expect the leveraged leg FAZ to outgain the losses in XLF, and XLF is basically going to oscillate around zero. And so the strategy is going to lose a lot. So we're not going to gain anything on the upside, and we're not going to gain anything on the downside, and we're just going to keep losing because of the decay of the FAZ, of the leverage leg. When it's bearish and we have moderate to low, excuse me, and we have moderate to low volatility, it's going to depend very much on the sequence of returns, whether or not it's slightly negative or break even or just negative. And so here we are with the exploratory analysis. Here we can actually look at it here a little bit bigger. So these are just the raw returns of the pair had you invested in it and held. And so we can see most of the pairs actually end up positive over time, except for XLE ERY. Here we are looking at the regimes, the volatility regime relative to the correlation regime, and the correlation is between the two legs, right? So in QQQ, SQQQ, the correlation regime would be how correlated is QQQ with SQQQ, as well as how volatile is the pair. So you can see that we have low volatility, low correlation, low volatility, medium correlation, and so on. And so what I think is interesting is we would expect that high volatility, lowest correlation, in my opinion, you would think that that would have the most diverse or wide range of returns, but it doesn't. And it doesn't for all of them. In this case, for example, high volatility, high correlation has the highest. But when we look at SMH, SOXS, high volatility, low correlation has the highest dispersion of returns. TLT, TBT, high volatility, high correlation again, as well as XLY, ERY. But then XLF, FAZ follows that high volatility, low correlation dispersion again. The next row, we look at the Sharpe ratios relative to the two regimes. Without summarizing these into like a table, I don't see any obvious patterns. Obviously, XLE ERY has the worst performance during medium volatility across all correlation regimes. XLF FAZ, low vol, low correlation is really bad, as well as medium volatility and low correlation. SMH SOXS tends to do well regardless of regime. So that speaks to an overall market trend or economic trend that is not really beholden to these typical regime changes. TLT, TBT, we can see high volatility, low and medium correlation is pretty poor performance, as well as medium volatility, high correlation. So I say that to say this strategy could benefit from individual pair filters based on regime. And then the last exploration is just the annualized Sharpe ratio by year. And so we can see it's pretty diverse. So we would expect a portfolio of them to do pretty decently. And we can see that in a second. So I also ran a custom back test for the strategy. And what surprised me is that the overall strategy with these pairs is decently correlated with SPY. So that kind of surprised me, to be honest with you. But volatility is lower, and Sharpe ratio I think is similar. I don't remember what the SPY Sharpe ratio is over this time period. For the portfolio, it was about 0.8, which is pretty decent. Max drawdown, we can see, is almost 20%. And it really underperformed from 2022 into mid 2023. And so we can just kind of look at the returns, rolling Sharpe ratio, trading costs based on when it happened. So in this back test, we use slippage as well as commissions, but that can be modified. And again, the code is in the GitHub. I don't know why this is so hard to see. The opacity might not be dark enough. And then we have our cost, cumulative costs, and the amount of cost drag in the portfolio. So this is basically the difference between the gross returns or the gross equity curve and the net equity curve. And it's a function of our trading activity. Again, the correlation between the strategy and SPY was roughly between 0.6 and 0.7. Some things to improve if you want to take the strategy and work on it yourself, or for me, this is what I would probably look into further researching. The portfolio weighting scheme is extremely basic, right? We're using equal weights, but it may improve by incorporating volatility and momentum into the weighting scheme. As we saw with the exploratory analysis, that the performance of the pairs varies based on volatility as well as correlation. So there might be a good use of volatility regime filters, on the portfolio as a whole, and each pair individually could benefit as well. One thing to note is that the strategy is very sensitive to the rebalance frequency. So what I noticed was the more frequent the rebalance, the worse the performance. And the way I set up the back test was that the individual pair would be rebalanced if the portfolio weight of the pair deviated beyond some threshold. So I don't want to go too much deeper than we already did. Again, this is just a toy strategy to implement to keep it interesting, and we're going to go through this in more detail, how to actually implement this using AWS Lambda in the next YouTube video and the next blog post. So if you want to join the conversation, join the Discord. If you want to reach out to me directly through email, you can do that as well. But other than that, thank you for your time. And if you have any other questions, feel free to reach out or drop a comment.